Ladies and gentlemen, this is Joe's Classic Video Games, back with another Rock Ola Jukebox repair video for you today. We're going to work on the PC board, the CPU of this Rock Ola 496-1. This is a really interesting one that we get from time to time. It has the System 4 control unit, they call it, or is this System 3? System 3 control unit, I'm sorry, 55130-A. So this was their last 45 bucks. And so you see these from time to time. It will have that cover on it if you've got the one. This is not to be confused with the shorter one, which was the System 2, but it may be very similar once we get into it. So we have the cover off of it. Here is the actual board. That's what we're going to be working on. So the problem that we're having, the first thing to look at, of course, on these is whether or not the battery has leaked. And on this one it has been removed, and there are some wires coming off of it. It did have a remote battery holder, but I think we pulled it off because we were using it on something else or something. But so there is no battery installed. There's just a couple wires soldered to the place that the battery used to be. But what this one is doing is none of the inputs and none of the outputs are working. So when you turn it on, I've got it in off right now. If you turn it on, basically it just runs and runs and runs. Now you're going to hear a clunk here in a minute. There's something going on with the dog on the side. So it all sounds good. When it gets back to the home position next time, you hear a big clunk. Okay, so it's just doing this over and over again. We've repaired the power supply. We think it's all good, but we'll check as we're going through. But I think it's on the board. So the light that is on is, it says default pricing. Again, we've got the cover off, but it's this default price light is on, okay? Which is fine. It will run like that. Basically, it's saying that the battery has been removed and you haven't went through and set up all of the pricing structure on it, but it'll run like that. But it's just running non-stop and will not stop. Now, on this particular one, we have a problem where there's no schematics for this version that I can find online. I'm sure somebody's got them. I just don't have them. I've had people send me schematics for the 496, but it's not quite the same thing. The 496 used the System 2. This is the 496-1. They use even a new setup. So it's just a little bit different. So there's no home switch, at least that I can find, on this machine. It must be using the encoder wheel here on the side to find the home switch. Now I've got the lid propped up on that power supply. It had even worse problems, but so it must be using this encoder wheel on the side to find home. There is a spot whenever you get to home or near home. Let me see if I can get it to on this encoder wheel. See the spot there where the holes stop? So I believe that's how it knows that it's at home. So I think that's working correctly. That's my theory, at least. But the board is basically not handling it as an input. It can't tell that it's at home. On this particular model as well, there is a mechanism board back here behind the turntable. So it's a little different setup than you usually see on the older ones. I think I have another one here I can show you up close. Maybe. I got parts everywhere. We're in a Rock Ola fixing mood. Okay. So here is that board that's down there. Okay. It's the Mech Power Board 55180. So there's two relays in it. And so basically that's the sensor is talking, well, this has no microprocessing power, so this can't really tell anything. This is just going to be used to basically power the motors and stuff, but basically that should send a signal that it's at home back to the PC, which should interpret that, and then send a signal back to this board to tell it to stop it at the home position. And that's not happening. So I'm trying to figure out what the deal is. We don't have schematics for it, but we have schematics for similar systems. So we have the schematics for the System 2, and we have the schematics for the System 4, but just not the System 3, the one we need, right? Another thing that's going on is the display is not working. The display had a just some gibberish on it, and I changed the ULN 2803, which kind of drives the displays. And once I did that, now the display has nothing on it, but I think that's correct, because I think the gibberish that was on it was just because that chip was shorted. So we got to figure all that out as well. So we're going to have to pull out the logic probe and see if we can work through this thing a little bit. It seems to be booted because where we're at here. Now this top button is the advance button. Whenever I hit that, we do advance through the different settings. Now if I was to hit this one, for instance, this turns it on free play. It bounces back over to there like it should, but it is not displaying that is on free play. When I had the other chip in, and I'll show you the schematics here in a minute that I've got so that we can try to figure this out, but whenever I had the other chip in, there was a couple 9s on here, and then nothing would ever change. So it just would kind of stay with that lit up. As you revolve the basket there, it should read what record you're on, even though you're just cycling through. It would not do that. So what I think is going on is that this board cannot see any inputs and it cannot make any outputs. However, I just pressed those buttons and that's an input and they work fine. So hopefully that'll be enough clues to help us to kind of figure out the direction to look in. It's also lighting up the correct LEDs, which is an output. So that's working fine. So parts of it are booted and up and running. But the external stuff that hooks up with the ribbon cables and things doesn't appear to be working right. So that's where we're at. So I'm going to look at the schematics, and we'll look at a couple things and see if we can figure out what the problem might be and use the logic probe to test through it. Okay, folks, we're trying to figure all this out. So we're on jukeboxrebel.com. I love this site. They basically list all of the jukeboxes in order and all of that, and they also let you print a title strips for free, so we use them all the time. There's also pinballrebel.com, same people, and they have they house Incognito's pinball instruction cards, which we use all the time whenever we're missing the instruction cards and we need to print new ones. So anyway, they have a listing on here where it shows you like what order all the jukeboxes came out in. So we're messing with Rock Olas. These are some of my favorite ones, by the way. So in 82 and 83, the 488 came out, which looks like that. We get those all the time. 84 through 86, the 490 Super Sound came out. Those are very popular. We get those all the time. 87, the 494 came out. We've had a couple of those. And then in 87, the Nostalgia 1000 came out. So this was like an old school one that looked kind of like the old Bubbler jukebox, but that Wurlitzer did, but not quite. Very cool, though. So these ones I've worked on a lot, and I know that they use the System 2 control unit. This one here doesn't. It uses their profit setter unit, which I guess would be considered the System 1. These ones use their System 2 control unit. The Nostalgia 1000, I've never had one, but if you look at pictures of it here on their site, it also uses the System 2 board. So that's the System 2 control board. You can just tell by looking at it. It's a little thinner than the System 3, or it's not quite as tall as the System 3. So System 2, System 2, System 2, and then they went to the 496. So this is the one I'm working on. It uses what they called the System 3. Well, after the 496, which could play CDs, they went to the 498. So that was the 496 here is 1988. 1989, they made the 498, which could also play CDs. And then we got down to the CD era, and they re-released Or I guess that whole time they made the nostalgia. See how it says based on 494, 496? Okay. They made their Laser 2000, which was their first full CD box. I've actually got one of these. And so the Laser 2000 used the System 4 control board. So they abandoned that System 3 after just, I think, using it only in the 496s. It may be in the 498s as well. But the System 4 looks just like the System 3. Here, I'll show you. So here's their photo of the inside of it. You can see that it just doesn't have the push buttons in the middle like our System 3 board does, but it's set up very similar. Okay, so I have some schematics for the model 3000. Now the first CD one was the 2000, the 3000 was the second CD one, and of course it uses the System 4 setup. And so I've got this, and it looks so similar to the System 3. It's almost the same thing. But I don't have schematics for it. There's no schematics for it, unfortunately. But you can see that they built each one off of the previous one. So the 2, 3, and 4 are all very similar, and all came out within about 5 years of each other. So it is what it is. So I don't have schematics for a 496. I can't find them anywhere. I don't have schematics for a 498. I don't have schematics for a Laser 2000. I don't have schematics for the Nostalgia 1000, but I do have schematics. Oh, no, I don't have them for the 3000. I just have this service manual for the 3000. But look at this that I found. I'll show you something interesting. I hope you find this. Interesting. Okay, so here is the controller, you know, the keyboard. It's very similar to the ones on the 496. That keyboard looks almost identical to that. Okay, and then if you go down, oh, here is the layout of the inside. Very similar. See the gripper arm? It's just the CD setup. They've made almost exactly like the record setup. It's very similar. So there's our control unit. System 4 instead of System 3. If you go through, they start showing you parts. Or I believe they do. Yeah, so they're showing you how the box is made up, exploded diagrams, etc., etc. And we get to bam. The Mech Power Board. Have you ever seen one of these? Yeah, you have. I showed it to you just a few minutes ago. So the one in the 496 is the exact same power board. So the mechanism, even though it's playing CDs, uses that same board. So we're System 3. This is System 4, but I'm just showing you that it all works pretty much the same, right? 3s and 4s are very similar. And then if you go down, here is the display PC board. Have you seen one of those before? Yeah, you have. It was hanging in the machine. I've got 3 of these, right? So I've tried 3 of them, and none of them will give me a display. So it's obviously something on the computer. All right. So let me show you the schematics that I do have. So this is a wiring diagram for the System 2, and it shows the schematics for the System 2 board, which is laid out a little differently, but basically is doing the exact same thing. So I don't have ones for these actual parts, but, you know, we can kind of pick through it a little bit. So on these schematics, they show that there is a ribbon cable on the 494 and the 490 that connects here. This is like connections on a ribbon cable. And it connects up to the keyboard and display. Now remember, we don't have any digits. We don't have any numbers on our display, and I think that's a symptom of a bigger fault. That's my hope. So the way that it works is it's a very simple circuit. This is a different part number than the one we've got, but it's very simple. I've worked on the 490s before, and it's almost the exact same thing. Some of the signals come through, and they run to a ULN. Now the L is important, apparently. We'll see that here in a minute. ULN 2803. And that's a bunch of transistors basically inside that thing. And these lines come in, and they use that to go to two connections on the edge of the board, which connect to the light bulbs on the door to make them twinkle. So the controller is the CPU is basically in connection with that ULN2803 to make lights blink on the door. There is another one here on the board, the keyboard, the display board, to light up this. So you've got 3 LEDs on a 490, your selection, now playing, and add coins, and then you've got 2 light bulbs, a bonus light and a reset light. Okay. Well, on our little board, here is that ULN2803. I've removed it. I'll show you why here in a minute. And if you follow the traces, it does appear that that controls this light, that light, and those 2 LEDs. So 3 LEDs and a little light bulb. Why they didn't do 4, I don't know, but whatever. Okay. Now you can see an unpopulated chip up here. Right? Well, that would have been the other one that you would use this connector to connect to the door to make the lights blink on the door. And if you look at the back, you can see that that chip would just connect directly out to the harness that goes to the lights on the door. So that's what we're looking at here. Right? But since this particular model, they didn't do that. See the little dotted lines around it? They didn't put the chip on the board. So what I'm saying is this board that we have schematics for is very similar to this board, just slightly different. And one of the reasons is because it doesn't have push buttons on it. So on this board, there were little buttons that you press, and that's how you talk to the computer whenever you're selecting a song. Well, this one doesn't have it because they had a little jumper here so that they could use membrane buttons on the front of the keyboard, which have all failed, but we've got a solution for that. So that's one of the differences between this board and the board that we have. So that's how this works. So again, I'm just showing you that it's all very similar. The digit and segment lines come in here, and that's what runs the 8 displays. Okay. So here we have our same 8 displays. And I have looked at the pinout, and it's pretty much, best I can tell, the same. So the lines running to these, look, there's nothing on the actual keyboard, nothing on this actual board that make these displays work. It's all controlled by the CPU through that ribbon cable. Okay. So lines 9 through 16 pretty much, 9 through 17 run the segments. And then 18 through 24, 25 run all of the digits. So that what the digits do is they enable the actual display, and then the segments are strobed in, and they tell it, what segments to light to make the letters. All right. My whole point being, there can't really be much wrong with this unless the actual displays are out. There's one chip, a ULN2803. If I put it in the actual CPU, on all 3 displays that I have, it makes gibberish come up. And then if I put a brand new ULN2803 in, nothing comes up. It's just completely dead. So I think what's going on is that one chip is shorted, and it's just shorting stuff on. And whenever you change, whenever it scans through and everything, none of that ever changes. So I think it's just a screwed up chip. And then I'm putting brand new ones in. I've tried like 3 different ones, as well as some used ones that I have that are different makes and stuff. And no matter what I do, I can't get anything on the display. So that's where we're at. So I'm trying to systematically work through this and figure out where our problem must be. So where do these signals come from? This schematic originally was like a big, huge piece of paper, and the scan that I've got, they've broken it down into little pieces of the page, and they're laid out horribly. So it's really, you got to jump around to see where everything is. But there are our digits and segments. 15, 16, 17 are segments. And so if you come down here, this area here, this chip handles the segments. Okay, and if you come over here, this chip handles the digits. So since we don't have anything on, I was thinking probably digits, right? But then we run into another interesting problem. Now keep in mind, none of the inputs work either. So I don't think this is the issue. I think there's more going on. This is just what I've tried so far. That says UDN 2803. Best I can tell, that doesn't even exist. So I think that's supposed to be ULN 2803. I've searched and searched and searched. There's no such thing as a UDN 2803 as far as I can tell. Now over here you have UDN 6118. That's correct. I think the difference is one is PNP and one's NPN, I believe, but they don't make a UDN 2803. So I think that's a typo, and it's on about 5 different sets of schematics that I've got for the System 2 stuff. So I think it's just they screwed it up. It's a UDN, and you can see up here that on the keyboard they were saying ULN 2803. So I think that's just a mess up. And if you look at where the power comes in, see the 12 volts there? It comes in on pin 10. That's where it comes in on a ULN. So I don't know, folks. On the board, whenever I took the cover off, it had a ULN 2803 in there, which I assume was from the factory, but who knows? Right? And then here is what controls the segments. We have a UDN 2983 installed in ours. You can change the jumpers and put in a UDN 6118, which I've got some of those. Also, the LS273 are the buffers that feed it. I've swapped those, no dice. But if you look, it says E5 and F5. That's because these are the chips on the System 2. We're messing with System 3. It's a different thing. So, what I want to do is kind of track this down and see if I can figure out what's common to all this. Maybe there's a voltage missing or something, or the ground's missing, and so that's why the lights, the LEDs won't work, and the buttons won't work. I don't know. Okay, so I'm going to look through it a little bit and see what I can figure out. This is the 2 board set, and System 3 and System 4 are basically one square board, so they're laid out very similarly. Now, I have a little cheat sheet for the System 4 stuff, if I haven't lost you yet. Look at this bad boy that I was able to find. System 4 Control Computer Testing Procedure. Say what? Say huh? Start here. Remove cover and test inspect the battery. Must be clean and measure 3.6 voltage DC minimum. Replace if necessary. So I wonder if the whole problem is the thing just won't work without a battery. I don't know why that would be, but maybe. I know the System 2s work without a battery, but maybe System 3 won't. I don't know. So maybe we try that first. Clean edge connectors with fiberglass eraser. Connect computer to Jukebox and apply power. Okay, what happens? Does the display go through this? Nope. Does the display go through that? Nope. Does the display go through that? Nope. Does the display show garbage? See, ours can't even do like A and stuff. It's not going to be able to do that, but it should show something, right? Does the display show garbage? It did with that one chip, but I think the chip was bad. So I think we're over here. Display is blank. I think that's where we're at. Does the mechanism home 15 to 20 seconds after power up? It doesn't. They're saying that the clock might be missing, right? But I don't think that's our problem either. I think we've got a problem on the inputs and outputs. I don't think there's a problem with the program running, or else you wouldn't be able to use the advance button. So we're going to say that yes, it does, just to look at this. And then it says check display drivers, driver ICs U13 and U26 and associated circuitry. So that's kind of where I've been. But there's another spot down here with the clock. If the clock is not present, check the crystal and clock circuit. If the clock is present, check U18 pin 26. If low, check power up, reset circuit. C142 and 143 have a history of failure. Okay, you can also go over here, put up a credit, make selection. You can check to see what happens. Mechanism fails to move or always runs. That's kind of what ours is doing too, right? So maybe it's something with that. Check U36, Q6, Q7, and the run line. All right, so I got a little bit of stuff to help me get my mind around it. That's what I'm looking at, and I'll see what I can figure out, and then I'll film it. You know, really, just looking at the board, now I'm not, an expert at this stuff, but I can't fault Rock Ola for anything that they did here. I mean, this is a nicely made board. They made it, where they can expand it a little bit. And maybe it really is just the System 2 boards combined onto one board. But let's look it over. So you got a battery up here that I caught before it started leaking. I already messed with this because I had another one and I figured out this board was bad. Probably a year ago. The whole thing runs off a Z80. That's good, right? We've got a couple ROMs here. We've got a RAM, a 2816 RAM. No, I'm sorry, a 6116 RAM. 2816, I guess that's a RAM too. I guess one's for the backup, or the system. One is to store customer bookkeeping and stuff like that, and customer selections and stuff, and one is just to run everything, I guess. A 74159, which I don't know, maybe that's how they're running these LEDs. A Z80 CTC. Oh, isn't that something where it's like a PIA or something? That might be our problem, maybe. Got a little dip switch set up down here. Okay, and so then all of your inputs and outputs come in over here. This is the displays. And they have socketed almost every chip on it, which really helps, So this is our ULN 2803. Here, I already swapped it. That didn't fix anything. Here are our 74LS 273s that I guess buffer it. Swap them, that didn't change anything. I swapped these two, that didn't change anything. I don't have a UDN 2983, but I do have the other one, the 6118 or whatever it was. I've got that, and on the other board, the System 2, where it said you can use either one, and then you do jumpers A or jumper B. Well, it looks like they've got the same thing here, but they've called it jumper 1 and 2 here. And, depending on which way you have the jumper, you're connecting 12 to one pin and ground to the other, or ground to one pin and 12 to the other. So it looks like we can swap that if we need to. And it's just everything's socketed. The buttons are nice quality buttons. So, I mean, it's a cool board. Their earlier stuff, like the Profit Setter boards, ran off 9.6 volts, which kind of sucks, But this is all common stuff. This is a good board, but they abandoned it almost immediately and went to the System 4. My thought is the System 4, I'm sure, is just a slightly modified version of this. So I'm going to put the battery holder back on it and make sure 3.6 volts is on it, and then we'll go from there. I also went through and replaced some of the capacitors, but I had already done that before, so I guess that's not going to be the problem. I've already been trying to get this thing working in the past. But we'll do the battery thing first, and then I'll pop it back in and make sure it's nothing as simple as that. So this is the old school way I do the batteries. Just get a 4 battery holder and put a blocking diode as the last battery, connecting, with the line connected to the red going out. And then 3 batteries is 4.5 volts. The diode drops it a little bit, and it makes it where the board can't try to charge them. I don't think the board is trying to charge them, but just in case. So it's going to drop the voltage down to like 4.2 or something. Of course, usually all the batteries are high, so it'll probably be higher than that. We'll find out here in a second, won't we? I bought these. They have a little switch on them, which is about useless. I sold one. I put one in a pinball, And when the guy got it home, it had knocked the damn thing on off, and it made it forget all of its settings. So he had to go all through it and reset everything back up again. So I don't really like that. But let's see if we've got at least 3.6 volts. Chopstick time. 4.6. That's even better. Okay, so with the battery installed, of course, it's doing the exact same thing. I figured it would, but just make sure, since we're following along with their troubleshooting guide. Okay, so looking on the schematics of the Series 2 computer, or whatever it's called, we have this chip, 74LS138, and it's being used to control. Send all these control lines out. DX770, 777, 7074, 771, 772, 775, 776. So it sends all these lines out, and they come up and they control the buffers that are used to turn on the displays. And then they're also used here where the buttons are used on the keyboard. Right? So I think that might be next. I guess I'm just going to swap it because it's so easy. It's in a socket. But I'd kind of, eventually I want to get the logic probe on it and see if I can just see if everything's dead or what's going on. But I think that might be an easy one to well, it'd be better to just check the signals, wouldn't it? So I need to, it's E4 on the system too, but on ours it's a, we're just going to have to look for a LS138 that seems like it connects to the area that's doing that has the UDNs, which are the obvious display chips. So let me see if I can find a place to get 5 volts in ground, and we'll try to put a logic probe on it and just see if anything's happening on these chips. There's an initializing light here. That comes on, and then it goes over to operating and normal operation or whatever it says after about 4 or 5 seconds. So it's up and doing something. And if you hit the advance button, like I said, it advances through it, which tells me it's running code, right? Even though the voltage is low, 4.65. But if you check, you're getting plenty of action on the processor. So I figured, well, let me just start looking through some of the signals and see if I can track it down and find something that ain't acting right. So again, without the schematics, we're kind of, just guessing here, but these are fairly similar. But if you look, they run off 12 volts, these UDN chips. But we could check the inputs to them, couldn't we? So UDN 2803 and the 6118 or the 2983, 1 through 8 are the inputs. 2 and 7 look suspicious, but we'll see. It looks like that's how it is. 1 through 8 are the inputs, and they're coming from the 273s right beside them. So these are our UDNs. And if we check 1 through 8, low, 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 low. Well, that would explain why we don't have anything on there. Our segment is completely, they're all dead. Now that one, a couple of them are dead, but that's the digit one. So if it was telling it not to turn on a couple digits, that might be correct. I don't know. Right? So let's move back from that. So I'm thinking this one might actually be working. But this one isn't. And I've swapped that chip. And again, this is the one, it says UDN, which I don't think exists. So let's move back to the 273 and see if it's getting what it's supposed to get. So I'm curious about, since it's completely dead and I've swapped this chip, I'm curious about its enable lines, so 1 and 11. Now you can see that the data lines, the not data lines, the inverted data lines coming in are the same for both chips. They're just in different spots. So pins 1 and 11 though are interesting. So both of these are 273s, but you can kind of tell that this one is directly connected and this one is directly connected. Okay. Pin 1 is high, pin 1 is high, pin 1 is high, pin 1 is high. Okay. This one, pin 11, this is the one we think is working. Pin 11, pin 11, low. So the segment one is low, and that's why it's not outputting to that. Interesting. So this one ain't doing nothing. This one is. Right? And the difference seems to be this pin 11, which is coming from, it's DX 777, which is pin 15 of a LS138 around there somewhere. I can't go by these letters though because it's the wrong board, but there should be an LS138 that seems to be driving all of those with inputs on 1, 2, 3. And maybe 4, 5, 6. Are those the inputs? Let's see if anything's happening on 1, 2, 3, 4, 5, 6 of an LS138 somewhere near there. Okay, so that is a 74 LS138, and that is a 74 LS138, and I can see a few lines running from here down here. So maybe that's it. Let's see what the inputs are like. Six is low. Probably supposed to be. See, I don't know what they're supposed to be. Boy, didn't that one sound so much healthier? Okay, so this one has something on 6. Okay, so yeah, maybe we just swap those. What do you think? What do you think I just swapped that 74 LS138 and see what that does anything? So here's the one we're looking at that controls the displays and stuff and buttons inputs. And the other one is over here by the Z80 and the Z80 CTC, whatever that is. And one of the lines goes down and controls the mech, like the home line that we're talking about, and the run line, which tells it to turn on and all of that. So I don't know. Maybe they're both bad. Maybe I'll get lucky and they're both bad. But let's try swapping one of them and see if it just changes anything. I have swapped it. Let's turn it on. You can see it do its boot thing. If I can reach the power switch. That's more like it. It's missing one of the segments, but it's at least doing something. Let's see if I can put it on. I know how to put it on free play, even without the cover on it. Yeah, look, now we're getting somewhere. If you go over to here and then you hit this one, that puts it on free play, or I thought it would. Okay, I don't think that though would have anything to do with the mech, but at least now we can kind of see something happening. Man, we're making progress. So this is probably just going to keep spinning and spinning. There we go. See, it is actually, it's counting the records as it goes. So it knows where it's at, so it must be seeing that sensor. It's just continuing to run for whatever reason. But that's definite progress. Okay, so we're missing one of the segments though. That could just be, well, that might be a loose ribbon cable, or it might be, we might still have problems with that same little area with that same IC. Let's see if we can figure that out. So I guess that has made those inputs different now. I don't shock myself to death. 1, 2, 3, 4, 5, 6 is low, 7, 8. Okay, so input 6 is low coming out of the 273. Okay, so it's segment C of each one, right? So it's segment C, which is pin 12. I checked the entire wrong one. This one is the digits. This one is the segments. Okay, because pin 13 is output pin 15 off of that, which may be input pin 4 if those directly line up. So let me see the 1 through 8 on that one. Okay, so on this chip, pin 2 and 3 are low. They're not pulsing, which would mess up output pins 16 and 17, which would be wiring pins 11 and 12, which, let's see what it is on the other screen. 12 is segment C, which is missing, and 11 is the decimal. People, we don't need no decimal point. Why would we need a decimal? You don't have to have a decimal point. It's not even hooked up on the... That's not going to even have anything going to it, I don't think. Come on now. That's completely not necessary. 5, 6, 7, 8, 9. Trying to see if it's actually hooked up. 5, 6, 7, 8, 9, 10. It is hooked up. I don't know why you would need a decimal point on a jukebox. Come on now. We don't need that. All right, so we need to see why that 273 is not outputting a couple of them. We'll see if there's an input to it. Okay, so both of the 273s, they get D0 through D7 inputs, but it's actually not D0 through D7, you know, because it has the line over it. In the absence of D0 through D7. And if you look over here, see it says inverted data. So this is the data bus here. And then the lines run from there through a couple 74 LS04s, and it inverts it to make the inverted data bus, which is what's used for all of this. I have no clue why, but I'm sure there's a good reason. It must have been because those chips wanted a certain way, like the Backstreet Boys. Tell me why. Okay, so we're going to have to test the inputs, actually. That's what we need to do. So 3, 4, 7, 8, 13, 14, 17, 18. 3, 4, 7, 8, 13, 14, 17, 18. All right, now you guys remember the numbers, right? So it was, so this is the one that's working. 3, 4, 7, 8, 13, 14's missing. 17, 18. All right, 14's missing. All right, so doing the next one, I wrote that down. 3, 4, 7, 8, 13, 14, 17's missing. Oh, I'm on the wrong one. 13, 14, 17's missing, 18. Actually, 17's low. Okay, so on this one, 14 is missing, which is not D4. And on this one, 17 is missing, which is not D4. So our inverted D4 is missing. Now it is right here. It comes through what on this is F4, but there's two of them that do it. So there's F4 and H6 are both LS04s. But again, wrong schematics. Same design, different schematics. So I need to find some LS04s, 04s, and then find one of them that 3 works and 4 doesn't, or whatever. I need to find the one, I guess, that pin 4 is low on. Okay, 3 and 4 on a LS04. All right, so both of these are 74 LS04s. 3 and 4, so the input and output's working. And on this one, there we go. 3's pulsing, the input's pulsing. The output is stuck low. So let's try replacing that chip. That has brought back our missing segment. That is so cool. All right, well, we've still got a long ways to go, I think. Let's put it backward and revolve. Yeah, that's pretty sweet. I wasn't able earlier to get it to do the free play thing. Yeah, okay, but there it shows you there that the display is working. Ooh, we do have a decimal point when it wants it. If I could ever get the free play to work, it would say 99. Wouldn't that be great? Yeah, I can't get it on free play right now, but that's neither here nor there. We got bigger problems than that. Okay, so I've still got to get the buttons back in it and test them. Now, let me show you that real quick, and then we'll call it a night. This has been a 10-hour video. This is what the original control panel looks like. And what they did was they used a membrane similar to how the dart boards work, which is bad news long term, because what happens is you can get all kinds of problems. You can get just dirt inside of there where the thing, or corrosion where the things won't connect anymore, or you can get basically if it breaks, you're done. You know, if any of these traces snap, you're done. Okay, so that's a real problem on a lot of these. So what are we going to do? Well, I don't know. We could just drill holes in it and put a bunch of buttons. So we took one that was in decent shape, drilled holes in it, and then just put regular buttons in it, and then made our own little connector. So stay tuned and you'll see more of that. So I hope you enjoyed it, but this is about all I can do in one video. It's been like 4 hours, I think. So leave your comments below. Let us know what you think so far. Now that I've got the display working, it'll be a little easier to diagnose. Now, I mean, the power is still low. I don't, you know, I guess maybe it can just run on 4.65. Seems low to me. But maybe now we can, ooh, I wonder if one of those chips being bad was lowering the voltage. Let me check the voltage real quick. Nah, it's still about the same. It's 4.76 on this side of the diode. So, I don't know. Something's still kind of bringing it down, I think. But we'll figure it out. So, or hopefully we'll figure it out. I guess if it still works, we won't need to figure it out. But that's where we're at so far. So I hope you enjoyed it so far. Next time we'll figure out why we're having the problem where it won't stop at home position. And then we'll see if we can get it to play. But yeah, like I was saying, the design of this board is pretty good in my opinion. Maybe some of you folks that really know your PC design, your PCB design, can tell me down below if you see any obvious flaws. I'm not really sure I like what they're doing with the 5.7 to 5 volt, especially since it's not working right. But other than that, it's very well laid out. Even though I don't have the schematics, I can use similar schematics and still figure it out because it's pretty well laid out. It all kind of makes sense. And that's that. So we're pecking through it even without the schematics. And if one of you has the schematics, hook a brother up. Email them to me. The link is down below. I need the 496 schematics or the laser, the laser 2000 schematics would work because it's so similar. I don't have the System 4 schematics or the System 3 schematics. And if you think you've got the 496 ones, open up the file and look at it first, because the ones that are labeled 496 are not 496 for whatever reason. There's a bunch floating on the net, but they're not the right ones. So I appreciate everybody that's been watching. Make sure to give us a thumbs up. Hey, you want to know how you can help our channel? You can send me those schematics. You could do that. And also, if you're going to buy anything on Amazon, use our link to go to Amazon. Don't type Amazon.com. Don't do it, not even once. Use our link down below, and just by clicking the link, you don't have to sign up for nothing. It doesn't raise your prices. It's just, this is an advertisement for Amazon, you know, to them. And so it pays me money, but just because you click the link, because I sent you to Amazon. So we appreciate that. It gives us a little percentage of whatever you buy. So a lot of people have been doing that, especially here around the holidays. It's been pretty cool. So thank you for that, and I hope you enjoyed the video. Last but not least, don't forget to check out my brother Donnie. My brother has his own channel here on YouTube. We're always working on jukeboxes, arcade games, pinball machines. Look at all this stuff. I can't even get into it. Look at all the, we got stuff everywhere. I need to call Shango about this one. I can't do that, and I'm not good enough for that. We'll figure it out eventually, though. But we do videos on all this stuff. Donnie does videos on old buildings, old cars, old trucks. He and I are about to start a whole series on rehabilitating a mobile home. And before you think that won't happen, we already did one. We got an entire playlist over there where we fixed up a mobile home. So check that out if you haven't already, and we will see you on the next video. So I'll do another one on this one where we're wrapping it up and figuring out the rest of it and getting it going. I've been meaning for a long time to kind of delve into one of these CPUs just to figure out how it ticks, where I'd be a little more comfortable working on them. So I'm happy to see that I've at least made it just a little bit of minor progress, even if it was just figuring out why the displays won't work. So give us a thumbs up an odd number of times, and we'll see you on the next video.